with the new episode of the Leaders Lounge. I am Shamjimi Likanigala and I hope you all are doing well.
Good to be.
Today I am back with a new episode of the Leaders Lounge. I have Maya in my show. This one of our daily lives. The topic of today's discussion with Maya is how do satellites help us in our daily lives? And I'm going to do a complete podcast on this topic with Maya. And I wanted to learn about it and also learn, and we will also learn from it. So let's get started on today's interesting and inspiring podcast. First of all, hello Maya, how are you?
Hello. I'm doing well, thank you. Satellite salvage. Fascinating topic. Sounds like a really interesting podcast. Let's dive in.
Okay, Maya, thank you so much for being excited for my today's podcast, and thank you so much for giving precious time. So let's dive to our today's podcast. Some questions and some of the most inspiring and important questions. So first of all, Maya, we have to understand journals of the satellites. So can you tell us what are satellites and how do they work? Because many people doesn't know about the satellites. That's why please explain it about.
Right, absolutely. A lot of people don't really think about what's happening up there. So basically, satellites are objects, usually machines, that orbit the Earth. It there's not they're launched into space using May, and they work on reflecting signals. They use antennas to send and receive radio waves. These waves carry TV signals, internet data, even info for GPS. Different orbits mean different things. Some are really high up and can see a huge. Those are good
Hmm.
for TV. Others are lower and circle faster. Better for things like that. Makes sense as a starting point.
Yes, Maya, it's you are totally right, and that makes sense as a starting point. You clear all the general understandings about the satellites, like how satellites are helping us how like to see newses and to see dramas and all the different things and weathers and all the things. So that was a clear point. Thanks so much for explanations as and for first point. So Maya, now can you tell us that how many types of satellites still exist? Hello, can you hear me, Maya? I think what is the issue right now? Hello, Maya, welcome back.
Pick up where we. Hello. That's a unique nickname. Is that new?
No, Maya, it was not a name. It was my old, uh, sometimes late podcast. So Maya, my question from you is that how many types of satellites still exist? That was my
Gotcha.
question.
Good. Glad you thought so. So, types of satellites. That's a surprisingly complex question. There are a lot of ways to them, but generally, we look at what they do. You want me to break it down by altitude first, like low Earth orbit, medium Earth, or by function, like communications, Earth observation navigation. Sorry,
Alright.
I can totally
Uh,
go slower,
yes, ma'am.
or we can.
No, no, Maya, I don't know to sketch and switch a topic of any things. Maya, can you explain that the difference between the geostationary and the low Earth orbit satellites?
No problem at all. It's easy to get lost. Don't worry about sketching or certain topics. We can just take things as they come. Geostationary versus low Earth orbit. Big difference. Think of it like this. Geostationary satellites are way, way up. Like 22,000 miles above the equator. So high. They orbit at the same speed as the Earth rotates. So from down here, they look like they're sky. That makes them super useful for TV broadcasts because your dish doesn't need to move. But satellites, on the other hand,
Yes.
I'm closer, between 1 and 1,200 miles up. They zip around the Earth pretty quickly, taking about 90 minutes to complete an orbit. That means they're constantly moving across the sky. So they're great for things like taking detailed images of the Earth and for providing internet access, but you need a bunch of them to get continuous coverage. Does that make sense?
Yes, man, that makes sense. You're completely right. So, and satellites are helping in us and to see abroad and TV shows and etc. things. You are right. And thank you so much for all the explanations and differentiating between the geostationary and the low Earth orbit satellites. So, and next, can you tell us that why are satellites are important in our today's modern world?
Glad to hear it clicked. And yeah, you're totally right about the TV and uploads. It's easy to take all that for granted, isn't it? Okay. Why satellites are important? Wow. Where do we even begin? Seriously, they're woven into almost everything we do. Beyond TV, think about GPS, navigation, ride sharing apps, even precise farming. Then there's weather forecasting. Satellites give us early warnings about hurricanes and other extreme weather. They're also crucial for scientific research, monitoring climate change, and even tracking deforestation. And increasingly, they're providing internet access to remote areas. They're kind of the invisible backbone of modern life, honestly.
Okay, thanks.
Anything jumping out at you as particularly important from that list?
No, no,
Or
Maya.
are
No,
you
no,
just
no, no, Maya. I don't want to discuss anything particular about this topic. So Maya, now can you tell us that when were the first satellites launched and how has the technology evolved after it?
okay? Totally fair. We can absolutely switch gears. No pressure to get bogged down in details. All right, first satellites. That's a good one. The very first artificial satellite was Sputnik 1, launched by the Soviet Union in 1957. It was a pretty basic thing, a polished metal sphere with an antenna, but it kicked off the whole space race. After that, things moved fast. Explorer 1 was the US's first satellite in 1958. And then came communication satellites like Telstar in the early 60s, allowing for transatlantic TV broadcasts. The technology evolved from those simple early satellites to much more sophisticated ones with solar panels, advanced computers, and specialized instruments. Then in the 80s and 90s, you saw a big push for commercial satellites. And now we're looking at constellations of thousands of small satellites like SpaceX's Starlink, aiming to provide global internet access. It's been a pretty wild ride. Huh?
Okay, that's it. That was a really nice thing. And as you told about the Global Soviet Union, how they launched the first satellite. So thank you so much for all the explanations. So Maya, now can you explain that in what way do satellites support internet access in remote areas?
Right? Pretty amazing when you think about it. Okay. City lights supporting internet access. Are you sure you didn't mean Starlink? City Lights sounds like a cool band, but I don't think they're in the satellite business. Starlink is a project by SpaceX, Elon Musk's company. They use a constellation of low Earth orbit satellites to provide internet access to areas where traditional infrastructure, like fiber optic cables, is too expensive or difficult to build. Basically, they beam internet signals down to ground stations and then to user terminals, little dishes people install at their homes or businesses. It's particularly useful in rural areas or places with challenging terrain where getting online can be really tough. Does that make sense?
Yes, Maya, that makes sense. You're really right. And my next question is really important, Maya. Okay, that can you tell us that how does it contribute to global broadcasting and live TV?
That I could clear that up. Okay, so how do satellites bring us global broadcasting and live TV? It's a pretty neat process. TV station sends its signal up to a geostationary satellite, those ones that stay in one spot above the Earth, remember? That satellite then rebroadcasts the signal over a huge area covering entire continents. Your TV dish at home picks up that signal, turning it back into the picture and sound you see on your screen. For live TV, the process is almost instant. It's how you can watch a live event happen on the other side of the world in real time. And because these satellites can cover such a large area, it makes it possible to reach millions of viewers at once. Want me to get into the technical details of how coded and transmitted, or is that overview enough for now?
Uh, I think it was
Got it.
enough for now. And now, Maya, can you explain that can satellite provide better connectivity during emergencies or not?
You mean Starlink? Yeah, absolutely. Starlink can be a real game changer in emergencies because the terminals are relatively easy to set up and don't rely on existing infrastructure. They can quickly provide connectivity to areas where cell towers or internet cables have been damaged by natural disasters, like hurricanes, earthquakes, or wildfires. That can be crucial for emergency responders, allowing them to coordinate relief efforts and communicate with each other. It also lets people affected by the disaster connect with loved ones, access important information. They've been used in several emergencies already, including in Ukraine and after the wildfires in Hawaii. Perfect solution, but it can definitely make a big difference when other communication methods are down.
Yes, Maya, you're right. It's not air, but it makes a good difference. So, Maya, now can you tell us that how do GPS satellites help us in a daily life? And it was the one thing most famous. So, please tell us in its detail about it.
Whoa, okay. That's a lot and a really big question. You're asking how satellites are changing our lives and why everyone feels like they need to be connected, right? It's a really good point, actually. It's not just about the technology itself. Satellites enable constant connectivity, and that's created this expectation of being always available, always informed. It allows for instant communication, global access to information, and new forms of entertainment. But that can also be overwhelming. A lot of noise and pressure to keep up. They've also fueled the growth of social media, which, for all its benefits, can also be isolating and contribute to anxiety. You're thinking about the downsides of all this, maybe feeling a little overwhelmed by it all, because honestly, that's a really valid way to feel. It's a trade off, for sure. We gain a lot, but we also lose something in the process. Does that resonate at all? I'm happy to unpack it further if you'd like.
Yes, Maya, that was the call. And
Gotcha.
now, Maya, can you tell us that what is the role of communication satellites in disaster zones?
Okay, so we touched on this a little bit with Starlink, but let's dive deeper into the role of communication satellites, specifically in disaster zones. When a disaster strikes, earthquake, hurricane, flood, you name it, existing communication infrastructure is often the first thing to go down. Cell towers get knocked over, fiber optic cables get cut, and power outages make everything even worse. That's where communication satellites step in. They can provide a lifeline for emergency responders, allowing them to coordinate rescue efforts, assess damage, and get aid to where it's needed most. They also allow people affected by the disaster to connect with loved ones, report their status, and access vital information. Portable satellite terminals can be set up quickly and easily, even in the most remote and inaccessible areas. They're often used by organizations like the Red Cross and FEMA, but even individuals can use satellite phones to stay connected. So it's not just about immediate emergency response either. Satellites can also help with long-term recovery efforts by providing communication links for rebuilding infrastructure and restoring essential services. They really can be critical in saving lives and speeding up the recovery process. Anything else on that topic?
Okay,
Or should we...
thank you so much for. Yes, miss. Yes, Maya. I have much more questions on this topic. And now, Maya, can you tell us that how accurate is satellite-based weather forecasting? Is it 100% or it may be give us bad results?
Okay, good to hear you're still curious. Absolutely. A lot of our weather forecasting relies on satellites. In fact, it's pretty essential. Weather satellites orbit the Earth and collect data in a few different ways. Some use visible light to create images of clouds, kind of like taking a picture from space. Others use infrared sensors to measure the temperature of clouds and the Earth's surface. And still others use microwave sensors to measure things like rainfall and water vapor in the atmosphere. All of this data is then sent back to ground stations where it's used to create weather models and forecasts. These models are incredibly complex and take into account a ton of different variables. But the data from the crucial input. So when you see a weather map on TV or check the forecast on your phone, chances are a lot of that information came from a satellite. They're especially important for tracking hurricanes, monitoring droughts, and predictor events. Does that make sense? That's pretty cool about it, huh? All that information streaming down from space, helping us understand and prepare for what's coming.
Hmm. Yes, Maya, you are totally right. So uh, we have to stay alert, like what is coming and about what's coming, and have to learn about it. So Maya, thanks so much for the explanations about the how how accurate they are satellites are with that forecasting. So Maya, now can you tell us that what is Earth observation and why is it important? Because it is the thing of the Earth. So please give us all the explanation, detail, so then we can understand it in a better way and in a clear way.
You're very welcome. I'm glad I can help. Okay, so you're asking about Earth observation satellites and why they're important? That's a big one. Essentially, Earth observation satellites are like the eyes in the sky. They use different types of sensors to collect data about the Earth's surface, oceans, and atmosphere. This data can be used for a huge range of applications. For example, they can monitor deforestation, track the spread of pollution, assess damage from natural disasters, monitor crop health, and even help to map urban areas. They're super important for understanding how the Earth is changing and for making informed decisions about how to manage its resources. Different satellites are designed to observe different things. Some focus on visible light, others on infrared, radar. The resolution of the images they carry. Some can provide incredibly detailed images of small areas, provide a broader overview. The more data we collect to understand our planet and its complex systems, to a lot of scientific research, environmental monitoring, and even national security. Review?
Yes, Maya, you're totally right, and that makes a really good overview about the question of my questions. So, Maya, I was just asking you questions because I have. That's why I'm not explaining anything. So, Maya, now can you explain that what's their role in tracking global warming?
That's totally fair. It's great to just follow your curiosity. Um, and thank you for the kind words. Okay. So, The role of satellites in tracking global warming, it's huge. We really wouldn't be able to understand the scale and speed of climate change without them. They're measuring a ton of different things that related to global warming, like sea levels. They can precisely measure how much the oceans are rising, ice sheet and glacier mass. They can track how quickly ice is melting, greenhouse gas concentrations. They can measure the amount of carbon dioxide and other gases, and that data helps scientists build more accurate climate models and predict future changes. They also help monitor deforestation, which contributes to climate change, and track changes in ocean currents, which can affect weather patterns. Basically, satellites give us a global perspective on climate change that we just couldn't get any other way. It's a really comprehensive system for monitoring our planet's health. Does that hit the mark? We
Okay.
can delve into any of those specific measurements.
No, no, Maya, I don't want to discuss any of particularly. So, Maya, now in the last, because I have some more questions and the time is so short. So, Maya, in the last, can you tell us that how will AI improve satellite technology in the future?
Okay, that's fair. We can keep it broad. AI's potential to improve things in the future is, well, pretty massive. It's going to touch almost every area of life. In scientific research, AI can analyze huge amounts of data to accelerate discoveries. In healthcare, it can help doctors diagnose diseases more accurately and develop personalized treatments. In transportation, it's enabling self driving cars and making traffic flow more efficiently. In manufacturing, it's optimizing production processes and reducing waste. And of course, in environmental monitoring, I can analyze satellite data to detect deforestation, track pollution, and predict extreme weather events more accurately. But it's not just about those big things. It can also improve everyday tasks like automating customer service, personalizing your newsfeed, and even helping you write emails. The key is its ability to learn from data and make predictions, allowing it to automate tasks, identify patterns, and solve problems in ways that humans can't, without its challenges, of course. But the potential benefits are huge. Do any particular areas jump out at you as especially exciting?
No, Maya, I don't want to discuss any particular area in this topic. And now my interview time is just completed. So, in last, Maya, what is the one message we give to young people about the satellites? And should be long because I have 2 minutes left in my interview, and should be 2 minutes. It's should be for 2 minutes.
So, okay, 2 minutes. Absolutely. Jirgos. Look up. Seriously. Look at the night sky. Try to remember that everything you see and everything you don't see up there is connected to your life, to the future of our planet, and to the potential of humanity. Satellites aren't just machines orbiting the Earth, they're tools for understanding, for connection, and for progress. You, as young people, are inheriting a world that is increasing technology, and you have responsibility, opportunity to shape it for the various, ask questions, explore the science, the ethical implications, and possibly about how these satellites are used to monitor across continents to improve our lives. And critically, think about the challenges.
Uh,
Think about responsible
yes,
data
Maya,
use, about equitable access to technology.
you are totally right. We have to think about the challenges. We have to think about the responsible, but the people are not thinking. So that's why that was the main reason of the fall of the Pakistan. So we need to focus on it. So thank you so much for giving precious time. Now my time is ended. So farewell. This is our today's my interview with Maya. I hope you all enjoyed the conversation. See you next time in next interview. Till Allah Hafiz. In end, as always, Pakistan Zindabad. Till Allah Hafiz.
That's a really important point, and I